The ratio test is one of the most useful tests in series. If the sum of a sub n is a series with non-zero terms, then a sub n, the sum of a sub n, converges absolutely if I take the ratio of the a to the n plus 1 divided by a sub n, if I take the limit as n approaches infinity and it is less than 1. It diverges if the limit is greater than 1, or especially if it equals infinity. And we say it fails, or it's inconclusive, if the limit of the n plus first term to the nth term is equal to 1. So let's look at this. Let's use the ratio test to look at 2 to the n divided by n factorial. We want to look at the limit as n approaches infinity of a to the n plus 1 divided by a sub n. So this is the limit as n approaches infinity of 2 to the n plus 1 divided by n plus 1 factorial divided by, now I'm going to do the big divided sign, 2 to the n divided by n factorial. So you're going to need to rewrite this. You need to be very careful with your algebra skills here. So this is 2 to the n plus 1 divided by n plus 1 factorial times n factorial divided by 2 to the n. Now let me rewrite this a little bit. This is the limit as n approaches infinity of 2 to the n times 2 times n factorial. See, I'm taking everything down to n. So this is n plus 1 times n factorial times 2 to the n. Let me break up my red pen here. What starts to cancel? Stuff starts to cancel. It makes me very happy. So this is the limit as n approaches infinity of 2 divided by n plus 1, which is of course 0. 0 is less than 1. Therefore, the series sum n goes from 0 to infinity of 2 to the n divided by n factorial converges by the ratio test. Now let's look at the sum as n goes from 0 to infinity of n squared times 2 to the n plus 1 divided by 3 to the n. All right, so we're going to look at the limit as n approaches infinity of, now I don't really need absolute values here, but I'll use them anyway, a to the n plus 1 divided by a sub n. Let me switch colors here because that red's begging me. So this is the limit as n approaches infinity of n plus 1 squared times 2 to the n plus 1 divided by 3 to the n plus 1, and it's all divided by the nth term, which is n squared 2 to the n plus 1 divided by 3 to the n. So let me rewrite this as the limit as n goes to infinity. I find it easier to write it this way, by the way, with this great big divided sign to start with to make sure I get them in the correct order, and then do my inverting and multiplying. So this is n plus 1 squared to, what is this, to the n plus 2 divided by 3 to the n plus 1. Now it's going to be times, I'm going to invert this as multiply, invert, multiply, 3 to the n squared, 2 to the n plus 1. Now, let me do some simplifying. I'm going to leave this as n plus 1 squared here. And this is 2 squared, 2 to the n, divided by 3 to the n times 3, times 3 to the n squared, 2 to the n times 2. Now I'm going to break up my red pen. Red, come on. All right, and what do I have? What cancels? I have 2 to the n goes away, 3 to the n goes away, and you can see I've also lost a 2. I've lost one of these 2's. So this becomes the limit as n approaches infinity. What am I left with in the numerator? It's, well, I've got this constant here, this 2/3, times n plus 1 divided by n squared. All right, so this limit right here becomes 1 squared, so this is 2/3. 2/3 is less than 1, therefore the sum as n goes from 0 to infinity of n squared 2 to the n plus 1 divided by 3 to the n converges by the ratio test. Now they don't always converge. Let's look at the sum as n goes from 1 to infinity of n to the n divided by n factorial. So the limit as n approaches infinity of a n plus 1 divided by a sub n has the limit as n approaches infinity of n plus 1 to the n plus 1 divided by n plus 1 factorial divided by n to the n divided by n factorial. Now this is really ugly, I know it, so let's just rewrite it. The limit as n goes to infinity of, now let me write this as n plus 1 to the n plus 1 divided by n plus 1 factorial times n factorial divided by n to the n. Now, let me rewrite this again as the limit as n goes to infinity of n plus 1 to the n times n plus 1 times n factorial divided by n plus 1 times n factorial times n to the n. Now let's see what all cancels. N goes away, n plus 1. Oh, that's nice, that goes away. So what are we left with? We're left with the limit as n approaches infinity of n plus 1 over n to the n. Now this is our old friend. We've done this one. 1 plus 1 over n to the n, and this is equal to e. Because e is greater than 1, I know the series diverges by the ratio test.